This is Trig Identities Part 2, Day 3. Today we're going to talk about the half-angle formulas. Half-angle formulas allow us to take an angle, cut it in half, and still know the sine, cosine, and tangent of it, which is really cool. So someone sat down, figured these out. There's proofs for all of these. We're not going through all of that, okay? But it's going to handle, for the most part, the exact same way as we did for double angle. You find out where the angle lies, you draw a triangle, allows you to find sine, cosine, tangent, and then you evaluate for that correct piece. So, sine of u over 2, where u is the angle that is being cut in half, is equal to plus or minus the square root of 1 minus cosine u over 2. Cosine of u over 2 is plus or minus 1 plus cosine u over 2. Tangent of u has two options. It's 1 minus cosine u over sine, or sine u over 1 plus cosine u. Interesting. Two options, your choice, gives you the same answer. Now, you notice that we have a square root. In front of that square root, on two of them, is plus or minus. Plus or minus because sometimes sine is positive in the top two quadrants, sine is negative in the bottom two quadrants, quadrants 3 and 4. Cosine is positive in 1 and 4, negative in quadrants 2 and 3. So you have to, ladies and gentlemen, know where does the original u over 2 lie. If u over 2 lies in the first quadrant, then you'll know you're always going to be choosing a positive one because they're all positive in the first quadrant. If sine of an angle of u over 2 happens to originally lie in the third quadrant, you're going to choose the negative of square root. Makes sense? We know about that. All students take calculus. All schools torture children. Yeah? That's a saying that we all know. So, example number 1. There's only two, guys. Example 1, I want you to find the exact value of sine of 22.5. First of all, is 22.5 on your unit circle? No. So therefore, you start to think, wait, is 22.5 twice of an angle? If I cut 22.5 in half, I get 11.25. Is that one on there? No, I don't. It's not. So it's not a double angle. So I can't make it 2 times something. That was the last group. So now, wait a minute. 22.5 times 2 is 45. So could you rewrite this as sine of 45 over 2? Now remember, 45 over 2, 45 degrees over 2, is the angle of 22.5. I didn't change anything. Right? Now, we got to back up a little bit. We know we're taking the half angle now. We're going to use the half angle identity for sine, which is one of these. So let's right off the bat talk about, is this going to be a positive square root or a negative square root? What do you think and why? What's that? Positive. Why? Why is it going to be positive? What quadrant are we lying in? Because what's the angle? It's not 45. It's half of 45, which is 22.5. And what is 22.5? First quadrant. So that means that the half angle identity for sine of 22.5 is going to be a positive value. The sine of an angle between 0 and 90 is positive. Actually, 0 to 180, right, is still positive. So we know it's going to be the square root, and we're going to choose this one, which is 1 minus the cosine of u. What's u? It's not 22.5. U is 45. It's the angle that is being cut. 45 all over 2. Can you evaluate 1 minus cosine of 2, or cosine of 45 all over 2 and square root it? Yes. Yes, you can. You can find the exact value. What is the cosine of 45? Square root of 2 over 2. So, 1 minus square root of 2 over 2 all over 2. I have a couple different things going on here. Someone tell me 2 things that you can see that could be problematic. Give me one of them. Square root inside of a square root. Okay, so we can even say 3 things, I guess.
Negative square root.
It's a negative square root. What do you see a negative square root?
Negative square root. Right there. It's just a minus.
That's minus sign.
Okay.
So make sure not to lose signs or change or think something that's not the same. So we talked about the square root. What else do we have? Common denominators? Almost. What is that called? Complex fraction. Bless you. And the last thing is? A fraction inside of a square root. So I have to square at the top and square at the bottom eventually. Okay. So let's take care of the most inside piece first, which would be the complex fraction. Would everybody be okay if I changed 1 to be like a 1 over 1? Because that'll allow me to say, what is the LCD of all of that? It's 2. So does everybody agree that I should multiply it by 2 over 1, 2 over 1? And when I multiply by to the top 2 over 1, I distribute the 2, which leads me to say the square root of 2 minus the square root of 2 all over 2 times 2, 4. Everybody got that? What else can I do now? There's only one thing else left to do. Divide the 2 and the 4. What do you mean? You could technically separate to their own denominators, but then I wouldn't be able to do the next step. The only way I can deal with that square root, guys, is if it's a fraction. A single fraction. Because if they're added fractions, you can't square root 2 fractions that are added separately. So at this point, guys, I'm just going to square root the top and square root the... And what's the square root of 4? I'm running out of room. I'm moving it up here. Square root of 2 minus the square root of 2 all over 2. That's your answer. Square root of 2, or square root, sorry, it's the square root of the quantity 2 minus the square root of 2.
Whoa.
All over 2.
That's nuts.
Does anybody know what that is called? It's not messed up.
Complex root.
It's a complex root, okay, kind of, in a way.
Wow.
They call that nested roots.
Nested roots.
Nested square roots. When you got square roots inside of square roots. Or roots inside of roots. That's okay. Guys, that's an exact answer. I could take a calculator route, put that on the calculator, use in parentheses where it's needed. You guys should be able to tell me an approximated value. That's easy. You guys can do that on a calculator. Any questions?
No.
So, ladies and gentlemen, on these ones, guys, I'm going to change this up actually. I want you to find tangent of u over 2, sine of u over 2, cosine of u over 2. I want you to find all three of these. But guys, this is no different than what you did for the double angle. This is what I was talking about earlier. The difference that's here is just a different formula that you have to use. It's telling you it's in which quadrant? Second quadrant. Sine of u itself is 2/5. That's a positive value, right? That makes sense. It would have to be 1 or 2. So that'll help us as well when we go to cut it in half, whether we're going to use a positive square root or a negative square root. So let's start off with the sine, the writing it out first. So our triangle, because of sine of u is equal to 2/5, there's u. Sine is opposite over hypotenuse. So can you solve for the third side? Or the second side, or one of the sides. Second side, I guess. Which would be what steps? Yeah, 2 squared plus b squared equals 5 squared. 4 plus b squared equals 25. B squared equals 21. So b has to equal the square root of 21. Is that fully reduced? Square root of 21. Should I reduce that? What is 21 made up of? 3 and 7. Any partners? So it's good to go. Now, do it you just did for double angle stuff and say sine of u over 2. That's a u. That didn't help it. Sine of u over 2 is the square root. Wait a minute. How do I know if this is going to be a positive or a negative? What quadrant am I in? Second quadrant. U over 2, the original angle, puts me in second quadrant where sine is positive. Keeping a positive square root. Then it becomes 1 minus cosine of u all over 2. Isn't that the formula? Can we evaluate that, guys? How do I evaluate this? 1 minus what? Cosine of u. Here's u. You made a triangle. Adjacent over hypotenuse, which is square root of 21 over 5, all over 2. And now clean it up, clean up the complex fraction. The LCD is 21 over 5. The LCD is 5. Because this is over 1, this is over 1. So, square root of 5 minus square root of 21 all over 10. Done. Of course, now that's only done for sine of u over 2. Now we have to do cosine of u over 2. Hey, second quadrant cosine should be negative. So this is a negative square root of 1 plus cosine u all over 2. Hey, wait a minute. That's a square root, negative square root of 1 plus, we just did this one. What's the cosine of u?
Cosine of u is 21 over 5.
21 over 5. So instead of subtracting the 21 over 5, I'm adding 21 over 5. Then, again, I have an LCD problem. It's over 1. It's over 1. Actually, I don't have 1, do I? Wrong. Well, say, I'm in the wrong spot. Okay. This is over 1. This is over 1. The LCD happens to be, again, 5. So I multiply it by 5 over 1 divided by 5 over 1, which results in 5 plus the square root of 21 all over 10 with the square root and a negative. And booyah, we're done. Next, we're actually going to answer the question, the original question, u over 2, guys. Hey, guys, on this particular problem, if you remember back, we'll slide back on the pages here. There were 2 options. Let's look at those 2 options. A 1 minus cosine u over sine u, and a sine u over 1 plus cosine u. Which one do you guys want to use? They're both sine. They both have sine in them. Second one. Okay, let's use the second one. Second one was? Hey, wait a minute. Do you know sine u?
Yeah, you do.
What is it?
2 over 5.
2 over 5. It was a listed problem. 1 plus, what's the cosine? Ooh, wait a minute, guys. I got a question. Could we have done something wrong Could we have done something wrong for the fact of the cosine of u over 2? I'm thinking about this now. What quadrant are we in again? Second quadrant. Cosine of u should be negative. Do we even take any of that into account? And it's just like even the first one. I know, we did that way. But should we be taken into account? Because shouldn't that be a negative 21, square root of 21? Because it went backwards? I'm going to pause the video and we'll look this up, just to make sure. Let us continue with this. 1 plus cosine u. Let's make it a negative square root of 21 over 5, which results in a complex fraction here. If I multiply the top and bottom by 5 over 1, we would end up with 10 over 1 minus, or not 1, but 5, right? 5 minus the square root of 21. That also then would have to be fixed. Now, because we chose to use the sine u over 1 plus cosine u, it results in a denominator with the square root, which you would have to fix. So, let's just box this for now. Let's talk about what happens if you use the other formula. That other formula, remember, is 1 minus cosine u over sine. So 1 minus cosine u over sine u, which may be better because 1 minus a negative cosine u is square root of 21 over 5, which would be add. All over sine would be 2 over 5. Again, multiplying by 5 over 5 is what it comes down to. You get 5 plus the square root of 21 all over 10. Nope, made a mistake. Right here. Whoa. The mistake, guys, was right here. The 5s cancel each other out, leaving you with 2. these two are equivalent. One's fixed with the denominator having the square root, the other one isn't. They are the same. It does take a little bit of work to get one to the other, rationalizing the denominator. That one works out. The sine of u over 2 and the cosine of u over 2 don't seem to work out to the right answer, guys. I'm going to check into that a little bit more. But knowing this information, using this process, you should be able to finish worksheet 4 now. So that's your homework. Finish worksheet 4. Have a great day.